Welcome to Tech Talk IT, powered by Software Mind.
If you are a front-end developer interested in modern React's project structure, and you know how it will help with migrating the legacy code, this episode is for you. Hello everyone, my name is Bartek and I'm a senior engineer here in Software Mind. And in today's episode, we are discussing why having a well-structured React project is crucial. A clean, organized code base isn't just about aesthetics, it's also about scalability and maintainability. Where your project is structured well, it becomes much easier to add new features, fix bugs, and onboard new team members. We can think it like building a house. If the foundation is solid and layout is logical, making improvements or changes become straightforward. The same principle applies to your code base. A well-organized structure can enhance team collaboration, allowing developers to work independently on different parts of your project without stepping on each other's toes. Okay, and now let's dive into the key elements that define a modern React project structure. The first part will be component organization, first step when we want to define the project structure. And we should structure these components efficiently. You can group components by feature or functionality, making findings and managing related components easier. For instance, if you are working on a blog application, you might have separate folders for posts, comments, and users' profiles. Should we use a flat or nested structure? That will depend on your project complexity. A flat structure keeps things simple for smaller projects, but as your application grows, a more nested approach can help maintain clarity. Another critical aspect is separating logic from UI. This means using hooks and utility functions to manage data and state management while your components focus purely on rendering. This separation makes your components cleaner and easier to test, and container and presentational components are also useful here. Containers handle data, fetching and state management, while presentational components take care of displaying that data. This pattern encourages usability and consistency across your application. But what about the components itself? The good approach is to use atomic components concept. The concept of atomic components is all about organizing your UI components in a way that mirrors the natural structure of user interfaces. Just like matter is composed of atoms, molecules, and organisms, UI can be broken down into similar layers of components. So at the beginning, at the most basic level, we have atoms. In the context of React, atoms are your smallest components. This could be simple elements like buttons, input fields, or labels. They should not contain any state or complex logic. There are just simple, reusable building blocks. When you start combining atoms, you create molecules. A molecule might be something like a search bar that will include input field, an atom, and a button, another atom. So molecules start to bring together multiple atoms to create slightly more complex component that still have a single responsibility. Moving up in complexity, we have organisms. These are groups of molecules working together to form a distinct section of your UI. For example, a header or organism might include a logo, navigation menu, search bar, each of which could be a molecule or a combination of atoms or molecules. And finally, as you continue to combine organisms, create templates and pages. Template is layout structure that defines the overall design of a page without specific content, while a page is a template filled with content, ready to be rendered as a part of your application. What are the benefits of atomic component approach? The first one will be usability. By breaking down your UI into atoms, you create highly reusable components that can be used across different parts of your application. This reduces duplication and ensures consistency of your UI. The second thing, maintainability. Smaller components are easier to understand, test, and maintain. When component has a single responsibility, bugs are easier to track down, and the impact of changes is more predictable. The next thing is scalability. As your application grows, this structure allows you to manage complexity more efficiently. You can build larger components by combining smaller ones, making easier to extend your UI without overwhelming your code base. And the last but not least, consistency. With atomic components, your design system becomes more coherent, since atoms and molecules are reused across different organisms and pages. You ensure that your applications look and feel remain consistent. The next item, when it comes to the React structure, is a consistent naming for files and folders. The consistent approach to naming improves code readability and make it easier for your team to navigate the project. Next thing, configuration and environment management that organize your configuration files and manage environments variables efficiently. This ensures consistent development, testing, and production environments, reducing the likelihood of environment-specific bugs. This also applies to the concept of feature flags. For example, we are working on a feature that should not be in the production environment yet, so we can hide it behind the feature flag. Still, it should be present in previous environments like development or staging. And the next thing, tools and libraries. There are numerous tools and libraries available to aid modern React development. For example, we have Next.js, Remix, Gatsby, Vita are excellent tools for setting up your project. They provide a robust foundation, allowing you to focus on building features rather than setting up configuration. Also, TypeScript is another tool for React development. It helps catch errors early, improves code quality, and makes refactoring easier. Many teams find that using TypeScript can enhance development workflow and reduce bugs. And I think personally that TypeScript should be standard for front-end development. For state management, we have several options. The most popular are Redux, just React's context. Choose a solution that fits your project's complexity and your requirements. Personally, I prefer using context for less complex application or purposes like displaying alerts or handling the models. Additionally, UI libraries like Material UI and Tailwind can help you build beautiful and consistent interfaces quickly. Okay, let's shift gears and talk about migrating legacy code to modern React. This process can be daunting, but with a clear plan, it becomes manageable. So start by evaluating the current state of your legacy React project. We should identify areas that need refactoring or rewriting. Look for outdated patterns, performance bottlenecks, and parts of the code that are difficult to understand or maintain. Next, set clear goal and timelines for the migration process. Decide whether to refactor gradually or restart your application from scratch. Gradual refactor allows you to make incremental improvements, while a complete rewrite might be necessary if existing codebase is too problematic. When refactoring, consider introducing modern React features like hooks, because that's not obvious in every project. Break down monolithic components into smaller reusable ones, and that's not only makes the code easier to work with, but also facilitates testing and debugging. Next step will be updated libraries and ensure compatibility with modern React. Some dependencies might be deprecated, so replacing them with more current alternatives can be beneficial. Be mindful of potential breaking changes when updating the libraries. The most one will be a Node version and React version. And what are the best practices for a smooth migration? First, ensure that the user experience remains seamless, and users should notice any disruption during the transition. Also, testing and continuous integration are crucial throughout the migration process. Implement automated tests can catch issues early and use continuous integration to verify that each change doesn't produce new bugs. This approach minimizes risk and ensures the quality of your code. Finally, engage your team in code reviews and pair programming sessions. These practices promote knowledge sharing and help catch potential issues early. Migration is a team effort, and efficient collaboration can lead to a successful outcome.
Learn from our experts how to feel it, live it, be it. And make sure to follow us on social media at Life at Software Mind.